In most cases, when a truth table is needed, it is for a complex statement. For example 1, we will create a truth table for the statement not A and B. The parentheses are around not A so that we know the negation is for the A and not the whole statement. Completing a complex truth table uses a similar concept as the order of operations. We want to think about what order to complete the truth table. For this statement, we need to know what not A is before we can determine what not A and B is. We will start the truth table by filling in the first 2 rows with the truth value pattern we discussed in the previous video. The next column will be the truth value for not A. The final column will be the truth value for the complete statement, not A and B. To find the truth value for not A, we will look only at column A. This gives us false, false, true, true. To determine the truth value for not A and B, we will look at both column B and column not A. Since this is an AND statement, the only time it will be true is if both propositions are true. The rest will be false. For example 2, we will create a truth table for the statement A or not B and C. There are 3 letters in this statement, so we will need 8 rows. We find this by taking 2 to the 3rd power. If we had 4 letters, we would do 2 to the 4th power. To fill in the first 3 columns, we start with filling in column A with 4 trues, then 4 falses. Column B, we cut the pattern in half, filling in 2 trues, then 2 falses, repeating until the end. For column C, we cut the pattern in half again, filling in 1 true and 1 false, repeating until the end. Now we think about the order in which we need to determine the truth values. B and C have parentheses around them, so we need to find the truth value of that first. Once we know what B and C is, we can determine the negation of B and C as our second step. Once we have that, we can finish the truth table with the final truth value of A or not B and C. To determine the truth value of B and C, we will look only at the columns of B and C. And statements are only true when both statements are true. So I will mark those first and fill the rest in with false. Next, we will find the not B and C. This is just the negation of B and C. So we will write down the opposite of the B and C column. Finally, we can find the truth value of the complete statement. To do this, we will look only at the column for A and the column for not B and C. Since this is an OR statement, it is only false when both statements are false. So I will mark that and the rest are true. For example 3, we will create a truth table for if not M and P, then R. Now is a great place to push pause and try this problem on your own. Push play when you are ready to see the solution. First, we set up the first 3 columns using our pattern. Next, we will need to know what not M is. The next column will be the not M and P, and the final column will be if not M and P, then R. Not M is a negation or opposite of M. For not M and P, we look at just P and not M. Mark true for combinations that are both true and mark false for the rest. For the final column, we will look only at the column with R and the column with not M and P. Be careful with the order of an if-then statement. Since not M and P is on the left side of the statement, it is the hypothesis, and R is the conclusion. Remember that if-then is only false if the hypothesis is true, but the conclusion is false. We will mark the rest true, and your truth table is complete.